this is Ms. Wiles, and in this video we'll do an introduction to sequences. Now you may hear the word sequences and series used kind of interchangeably, but they're really not. The sequence itself is the list of numbers. The word series is more about the sum of the infinite sequence. So they're not really interchangeable, even though lots of times you'll see them used interchangeably, and they shouldn't be. So it's really just a set of numbers that are in a list, and they're ordered in such a way that there's a pattern, and you can figure the pattern out. And the pattern will either be an arithmetic sequence, where you're always adding a particular number to the number that came before, or a geometric sequence when you're always multiplying a number by another number. Every number gets multiplied by the same number depending on what you start with. You can tell by what you start with, and you can tell by the relationship between the number what is happening to all the numbers in the list. So let's look at some examples. Here's some examples. We want to find the missing numbers in the sequences. And I have 1, 2, 3, 4 sequences here. Without saying anything else, let's pause here so you at home can try to come up with those numbers. And we'll come up with those numbers in the class, and then I'll come back in and do a little summary of how we came up with those. For the first sequence, number 1, we look at that list of numbers and try to figure out what's happening in between the numbers. And the positive numbers may be easiest for me to look at, so I start looking at those. From the 3 to the 9, it could be that I'm multiplying by 3 to get from 3 to 9, or it could be that I'm adding 6. So then I look at the next set from 9 to 15, and I ask myself, am I multiplying by 3 or am I adding 6? And because I'm adding 6, not B, then I know that I'm adding 6 every time, or at least I think so, because it's happened twice now. So go back to the very beginning. Negative 21 plus 6 is negative 15. Negative 15 plus 6 is negative 9. Negative 9 plus 6 is negative 3. And then just to be overly particular, negative 3 plus 6 is 3. And I know that I've found the missing number. Not only have I found the missing number, but I've found a number that's called the common difference. The common difference is 6. And it's positive 6 because every time that I'm doing something to a number in this sequence to get the next one, I'm adding 6. Okay, hopefully you knew to pause, and if you didn't, back up a little bit in the video and pause so you can try to fill this in and find the common differences. But we did this in class. Number 3 here has kind of a method that was used using these last 3 numbers. The 24 minus 15 was 9, then checking that the 6 plus 9 was also 15, and found that the common difference was 9, and then you're able to go back and add 9 to any number in the sequence to find the next number. And that's all we have to say about that. Let's go on to some other types of sequences. Here's another set of sequences. And in this set of sequences, there's a couple of things you can notice that are different about these than the first set of sequences that I have. One of the things you want to look at when you look at a sequence is how quickly are the numbers increasing. And if the numbers are increasing much quicker than some other numbers that you've looked at, like all of these numbers over here, they're not increasing very quickly. But when you look at these sets of numbers, numbers are increasing very quickly. When they're increasing very quickly, they're more likely a geometric sequence, where you're going to actually multiply a number by a number to find the next number in the sequence. So instead of a common difference, you have what's called a common ratio. And that is designated by the lowercase r, which is used when you have the equations for these kinds of sequences. But you'll do something besides adding and subtracting to figure out what's going on. You're going to be using multiplying and dividing to figure out what's going on. So we're going to pause here while we look at it in class and while you look at it at home to see what we think goes in these blocks. back into the video and we see our answers, we see our common ratios, we see how we can figure out what the common ratio is. You could think that you're multiplying in number 3 here, you could think that you're multiplying by 3 to get the 9, but you also have to check that you're multiplying by 3 to get the 27, and these common ratios are very important. Something that I didn't cover in the first one, when you're doing an arithmetic sequence, it could be decimals. You could be adding a decimal value. Like if we have 2.7 and then the next number is 3.0 and the next number is 3.3 and then we have a blank and then we have 3.9. You can still have decimals and you're asking yourself the same question. If you know it's arithmetic, you're like, okay, what would I be adding every time? And we look at 3.0 minus 2.7, and we have 0.3. That gives us our common difference, which is 0.3, and then we know that what's missing here is 3.6. Now, similarly, in the geometric sequence, so far we had numbers that were just constantly getting larger and larger and larger, much quicker, but we could have some kind of sequence where the numbers are getting smaller. So I'm going to put a sequence up here. We'll start with the number 48. I'm going to leave a blank here. Then I'm going to have a 12. Then I'm going to have a 6. Then I'm going to have a blank. Then I'm going to have 1.5. Then I'm going to have a blank. In fact, I'm not even going to have a 1.5. I'm going to have a 3 over 2. And then another blank.
Okay. You want to start rolling this one?
Nope. Don't roll because I don't want you to have to figure out what goes here. Now, when you look at this sequence, you see a fraction which immediately makes your brain go mushy. But don't allow that to happen. Focus on what makes sense. And what makes sense the most right now is this 12 and this 6. The 12 and the 6 make the most sense, and it could be that it's 12 minus 6, or it could be that it's 12 divided by 2, because you should be able to see those relationships between the numbers, that 12 divided by 2 is 6, or 12 minus 6 is 6. So looking at those two numbers, it could be either one of those, but then we go back to the beginning. And if it's minus 6, then 48 minus 6 would be 42. But 42 minus 6 is not 12. So that one's out. So at that point, we're like, okay, it must be divided by 2. So divided by 2 is 24. And 24 divided by 2 is 12. And our common ratio is 1/2. Because we're taking half of it every time. And 6 times 1/2 is 3. And 3 times 1/2 is 3/2. And 3/2 times 1/2 is 3/4. So any one of those pairs of numbers, you could go into your calculator or into your handy dandy brain that you never leave anywhere and do 6 over 12. If you have those first two numbers and you want to find out what the common ratio is, 6 over 12 reduces to 1 over 2, and that is the possible ratio. Now, if you know it's geometric, that's just what you do. If you know that the sequence is geometric, take any two numbers, divide this number, the number that's furthest in the sequence, by the one that comes directly before it, and then you'll have your common ratio. So let's create another example of a geometric ratio that's just going down. So I'm going to pause here. No, I'm not. I'm just going to write it. We'll go with, give me a number.
17. 52.
I like 52. We'll go with 52. And then the next number is going to be 13. And the next number is going to be blank. No, I'm going to give you a third number because they usually do that. So we'll do 13 over 4. And the next number and the next number are blank. Let's pause here. All right, we're back in. The process from beginning to end is when you see something like this, the numbers are going down pretty quickly. It doesn't look like you could add or subtract anything to it, so you know that you're multiplying by something. Take the second number and divide it by the first number, or the third and divide it by the second, or the fourth and divide it by the third, but always the furthest number and divide it by the one that comes directly in front of it, and you'll get 0.25 or 1/4. Now, they're both exactly equal. 0.25 and 1/4 are exactly equal, but the 0.25 doesn't really show the progression of the pattern that's happening here. Once I know that the pattern is that we're multiplying by 0.25 or 1/4, then I would multiply 13 by 1/4 to get 13 over 4. Then I multiply 13 over 4 by 1/4, and I'll get 13 over 16. But look at what happened there. It was 4 times 4 is 16. 13 times 1 is 13. Then I multiply that by 1 over 4 again, and I have 13 over 64. And then the pattern continues on and on. That's a great place to stop for an introduction to sequences, and that's all I have to say about that.